Welcome to the session of AWS Lambda Best Practices Part 2. Let's talk about memory and execution time. So AWS has been charging for the Lambda execution based on the memory it uses and the execution time it takes. So these two factors are very important to understand because if you don't pay attention to this, you will end up having huge bill coming for your account. So first thing we need to understand is that allocating more memory is not always mean that it will be more expensive as well as it will reduce the execution time. So definitely when you are running a application which requires certain memory, if you increase the memory, the CPU allocation will be more and definitely it will reduce your execution time. But what if after a certain limit, it will not be able to reduce the execution time more because the maximum CPU allocation what it can do, it is already done, and increasing more memory will not help reduce it further down. Second thing is the more memory you put, the cost of that memory will be higher. Okay, so now you have to balance it out. The second thing which you need to know is that AWS charges you the execution duration in 100 millisecond blocks. How does it matter is, let's take a simple example. If you are running a application with the 128 MB memory and its execution time is 110, then it will be charging you for the 200 millisecond, which is the nearest rounded millisecond for which it can charge you. But now let's suppose if you increase the memory to 192 MB, your execution time will be decreased to the 100 millisecond. So here by saving the 10 milliseconds, you have saved the execution time of 100 millisecond. And that's the reason if you see the cost per invocation, it is reduced drastically, almost 25%. So this calculation you have to keep in mind. So there's no thumb rule of how much memory you should allocate to your function. It always depends on what kind of function logic you have. So let's suppose if you have a function which is more computation method like CPU oriented logic, search algorithms or your sorting algorithms are there, then increasing the memory will help you decrease your execution time drastically and making you more saving. But if your function does not need that CPU allocation, then increasing the more memory will just increase the cost for you and not reducing your execution time that much, and that will not help you. So don't go with the thumb rule of increasing more memory will reduce the execution time so that it should save more. That works only for the high CPU utilized function, but for other function you should use the Xrim monitoring, capture the logs, check the trend, and then make a call for that. Let's talk about the hottest topic, performance of the AWS Lambda, which involves cold and warm start time. So before we talk about how to improve the performance of a Lambda function, let's try to understand what is the meaning of cold and warm start. When a Lambda function gets invoked, there are certain steps happen behind the scene. First thing happens is that it will download the code and the dependencies which you have uploaded into the S3. Then it will create a container and do the initial setup of the container, which is the AWS container. Then it will initialize and start the code, and the last task will be code logic execution. Now the time it took from downloading the code to initialize and start your code is called cold start time. Why it is known as a cold start time is that when the next invocation happens for the Lambda, this cold start time will be almost zero because your container is already live, which is already done downloading your code, set up the container, and code has been already initialized and started. The only part will execute is your actual logic execution, which is known as warm start time. So the cold start time is a significant amount of time which takes for any Lambda functions to invoke, and that's the reason you will see tons of blogs talking about how you can reduce the cold start time, why it takes so much of time. So in this topic, what I'm going to do is I'm going to share some of the tips which can help you to reduce your cold start time as well as warm start time. The first thing I learned is that we should be using more interpreted languages than the compiled languages for Lambda functions or for any kind of functions you are doing, because interpreted languages like Node.js and Python, they are very fast in terms of initializing and starting the code compared to the compiled languages like Java or C++, and the dependencies are very heavy in those languages. Now let's suppose if you have to use Java only, and you most common framework in Java is Spring Boot, which developers use for building any application, right? So in Lambda function also they started using the Spring Boot MVC for dependency injection and started using to deploy that code as a function. But you need to understand that Spring Boot takes a lot of time to start the application, and so that's the reason Spring has come up with some other library called Spring Cloud Function, which is designed to create the lightweighted deployable, and that reduces the heavy weight of MVC dependencies like uh, web starter, test starter, and all those stuff. So even if you ended up using the Java, I would suggest you to use the Spring Cloud Function for your function development. Next part would be most in most cases you should be running your Lambda on default environment. We have discussed about it in earlier topic also, but it here I am talking about in the performance terms. As we discussed that when setting up the Lambda in VPC, you would need to set up the ENI for having the communication between the Lambda and other AWS resources, and ENI would also use the IP addresses, private IP addresses to have a communication. Now, setting up the ENI will take minimum 10 milliseconds. So if you use many ENIs, then it will add the execution time for the cold start for setting up the ENIs. So you should avoid using the VPC until and unless you need to access the resources which are running only in the VPC. The another way of reducing your downloading time for your code as well as your dependencies is that only put the required dependencies which are needed at the runtime as part of your package. When you write your function, try to identify the objects which are going to be long processing, or the objects which are required to have a DB connection, or the static variables which can be put in global scope, and define them outside of the Lambda function so that in the next invocation of the function they can still have the values loaded and no need to reinitialize those objects. That way you can reduce the time of your code starting. Okay, so the third step which we talked about, initializing your code and starting your code, will have a reduced time if you use this practice. Next one is, if you're using the Java, um, try to use the lighter dependency injections. Don't go with the Spring framework only, they are very heavy. So you can try out the Dagger or Guys. The next suggestion would be, if you're using Node.js, try to reduce the size of your function, because Node.js has come up with the recent upgrade of V8 optimizer, which will make your function as an inline function. To understand high level what inline function does, it speeds up your code execution. Try to reduce your code size to the 600 character only. Next one is about minification and uglification. These are the terms generally used in UI web-based applications, where we try to reduce the size of your um, static files, especially the JS and GS files, because that helps to load it faster on the browser. But now this particular feature has been more used in Lambda also, in function-based programming also, because you are using the Java-based application language, Java-based programming languages like Node.js. So what minification basically does is it removes all the spaces and new line characters and comments. So it will reduce the size of your code. Then if you are using the uglification, what it does is it will reduce the variable name length, or obfuscates them. So let's suppose if you have a variable name calling big array, it will reduce it to the variable name as a. Okay, so it will reduce the size of your variable name, and if you do it for all your variables objects, simplify them with the smaller name, then it will reduce the size of your code. So let's see a simple example how it helps us to reduce the size of the code. So if you look at the simple this code, it has around 11 lines of code, right? Now if I use the minification, it will become a 2 lines of code. So it has reduced drastically the size of your code of your file code. It will help you to download it faster, uh, heavily. Then if I apply the uglification, now if you see, the variables have been simplified and make it more smaller. So in one line of code only I can execute the same logic. So that is the way you can reduce the size of your file, reduce the size of your code. The next suggestion I would have is that in all the blogs, in all the documentations, you'll see around that AWS provides the AWS SDK library already loaded for the JavaScript. Right? So if you're using the Node.js as a developing language for function, then AWS SDK is already available. You don't need to put it as a dependency in your code. But that is actually a good thing in terms of performance, but there is a catch. The catch is that if there is any upgrade happen to this library, AWS will be upgrading it, and then you will be automatically using the latest library released by AWS with all the latest patches, and this might break your code if your code is not able to handle the latest version of this library. So it's always better to have your own dependency management, putting AWS SDK also as part of your dependency, even though it will impact your performance, but that is a good practice to handle it yourself. These are the ways you can improve the cold and warm startup time. Now let's talk about the security aspects of Lambda function. So in this topic, I'm going to discuss some of the best practices we should be following while designing the security around AWS Lambda. The first rule is that you should always have one IAM role attached to one function. You should not be sharing the same role with multiple functions. Taking an example, let's suppose one of the Lambda function needs access to the KMS keys. Now, if you share the same role across the Lambda functions, then all the functions will be having access to this same encryption key. So, always try to have one IAM role per function. That will ensure that you have the least privileges providing to the function. The second one is credential management. So in most of the cases, the IAM execution role itself should be sufficient to have you connect your Lambda function to other AWS resources. You just need to use the AWS SDK without providing the uh, secret credentials in the code and connect to that. And the Lambda will take care of automatically retrieving the temporary credential for that service based on the role access you have defined, and then use that temporary credential to connect to that resource. But in some scenarios where, let's suppose you want to connect to the cross account services. So let's suppose you have one VPC where you are running your Lambda function. Now you are connecting to a PostgreSQL database which is running to the another VPC. Now in this case, you would need some credentials to access to that AWS resources which is sitting in the different VPC. In that case, instead of hard coding the access key and secret key in your code, you should be using the AWS security token service, and that service provides a API called Assume Role API. This API can generate a temporary credential and give it back to you. You can use this to connect to the AWS resource, and it has a timeout uh, feature, so it will be active only for a particular duration. After that, it will expire. So that is the best practice you can follow to connect to any other AWS resources using the temporary credentials. Now, in some scenarios, you would need to keep the long-lived secrets also, where you cannot afford generating the keys again and again. Like take example of connecting to a database where the credentials have been generated one and you want to keep it for a long time. You don't want to keep getting the new credentials for the database, right? So in those cases, what you can do is you can put those secret credentials in the environment variable. Lambda, it provides a feature where you can encrypt those variables using the helpers. So you can use the AWS KMS key. Uh, so if you look at this, here you can add any password credential and put the password as test, and then you can apply the AWS KMS key to encrypt it. So if you can create your own custom master key, you can use the default key as well, and that Lambda will handle to encrypt this key, and then you can use that in your code using the AWS SDK, and then connect to that particular resource. You can even click on the button code to get the code for decryption, which you can use to decrypt a credential which you are setting up to the environment variable. So this code you can use it to decrypt and use it to connect to the database or any other AWS resources for which you are setting up this credential. So that is for the persistent secret to store. There is another option is called SSM, which is Secret Service Manager. This service is also used to store the credential with the AWS KMS key, and there are a couple of other options as well. The difference between the environment variable and SSM is that the environment variables are very tightly coupled with the function. So if you want to change the credential for a function, it will publish another version of it. So it will bump up the version when you are uh, updating your credentials in the Lambda. And that's why you have to make the do the version management in that. You need to point your alias to the latest version. But the SSM is totally decoupled from the Lambda function. It is a service which you need to call from your Lambda function to retrieve the credential. So there are advantage and disadvantage in this, right? Because if you're using the environment variable, it will be very fast because there is no extra code you have to write. It is just you have to load the environment variable. But in SSM case, you have to make even external service call. Uh, you have to write extra code and it will add up to your computation as well. But it is more decoupled from your Lambda. The third topic is about VPC security. Right? So as we know that Lambda function can be run on VPC as well. So in that case, you need to apply all the VPC level of security. There is a detailed documentation provided by AWS how to secure your VPC. But high level, you need to ensure that you are putting uh, proper subnets, Lambda function specifics only. You need to ensure to define the security groups, ACLs. So all the security standards you have to follow as per the VPC. Next topic is deployment access control. So when we set up the CI/CD for Lambda, we will be mainly calling two APIs. One is update function code and one is update alias. So when you do call update function code, it is nothing but a code deployment where you will be updating your code and this API to call to get it reflect the updated code for the Lambda. And the update alias is where you are bumping up the version and pointing to the latest version. So it is something similar to code release. So these two APIs are very sensitive, very critical because it can impact your customers as it will reflect the new code into the production and so you have to be very careful about providing the access to these two APIs. Ensure that these APIs are not accessible by the normal users with the direct access. It should be only allowed to get access through the automation of the CI/CD. So that is all about security of the Lambda function. Now let's talk about the testability. So Lambda function runs on the AWS only. How do we test the Lambda function before we deploy on the AWS? AWS has provided same service which you can download. What this service does is it provides a local environment where your Lambda function will be exposed as a API endpoint and you can test that. So that is one way you can test it in local before you deploy to the AWS environment. Second thing is, what you can do is, there is an open source project called Local Stack. This project helps you to build a local environment which is same as AWS. It can provide you all the AWS services like DynamoDB, S3 and all. It will expose them as a REST endpoint through which you can call those services and use them for local testing. One more thing we need to understand is that other than providing the local testing environment using SAM and local stack is that how you make your Lambda function testable. Because if you put all your logic in your function handler, then you cannot unit test them easily. For example, if I'm using the S3 objects in my Lambda function, and then I need to mock all those S3 connection object or S3 events to test it. To avoid that, try to separate your function logic, your business logic, and put outside your handler. For example, if you have a Node.js code, you can write a separate function.js which will have your whole functional logic, and you can call that, import that in your index.js, which would be your main.js file, and then call that JS file function method from your handler method. What are the objects you get from all the AWS services like S3 or DynamoDB? Convert them to equivalent to your domain objects and pass to that function, so that your function logic, which is residing on the function.js, is all about your functional and business logic, which you can unit test it. So that is all about testability. Next topic is blue, green and canary deployment. So when we talk about releasing our code, Lambda function is also like a normal application code which we need to release to the production, and most common pattern release is blue, green and canary deployment. So to do the blue, green deployment, we need to follow the versioning and aliases patterns. In Lambda, it does provide option to publish your code with multiple versions. When you save any code in Lambda, it will deploy your code with the version called latest, and that is the default version which will be invoked when you hit to your Lambda function. But that is not the standard practice, because what if you want to make any small changes to it and release to different customers different version of your code? That's where versioning comes into the picture. So let's see how this versioning works. So if we come to our test function, you'll see a tab here which is called action. Now here you will see an option to publish new version. When you click on this, you'll see that what are the latest version we have saved. It will create a new version to it. So let's suppose I say it's for client 1. I'm releasing this version. Now what will happen, you'll see a drop down here now which shows that now you're on the version 1. If you see here test function, there was nothing here, it was earlier as the latest, now it is showing version 1. So now if you see here, we have a version 1 here, and this is the latest version. Now similarly, if you make any small changes to this function, then when you publish it again, you can click on this and update the new version. Right now it is disabled because I have not make any changes. Once I make any change to this and save it, it will give me option to publish a new version. So that's the way you can manage the function versions. But now how will you apply the blue-green deployment with this versioning? Each version will have its own ARN. If you notice here, the ARN here has in the last version also after the function name. So if you use the versioning directly for the blue-green deployment, then every time you make a function code change, it will pump up the version to the new version, and then your customer, your clients who are consuming it has to also make a change to that version. And in this case, in Lambda case, your consumer will be mostly your API gateway, right? So your API gateway, again you have to keep changing your version number, which is not the right approach. So what we can do is we can use the aliases for that. Now how does aliases are different from the versioning is that aliases are giving the virtual name to your version, but behind the scene it will be pointing to a particular version only. So if you go here and create a new alias, now I can create a alias. Let's suppose I have a dev environment which is pointing to version latest, because I will be working on the latest code over here. So it will be always pointing to the my latest version. Okay, now I can create another alias with production, which will be pointing to my version 1. So it will create multiple aliases here. If you see, I have dev alias, I have a prod alias. Dev is pointing to latest, prod is pointing to 1. So now you need to remember that your changes are allowed to be done only in the latest version. All other versions will be mutable only. You cannot make any changes to that. You have to always make a change to your latest version and then publish a new version to be used by your consumers. So if we go to the latest version, and then let's suppose if I make a change, create a new variable called environment is QA. Okay, now I save this change, and now I create another version of that. Okay, so now still have the aliases which are dev and prod only. Now I want to point my prod to version 2. So now what we'll do, we'll go to the alias which is prod, and we want to point this prod alias to the version 2, because that is the updated version which we have published now. So we'll go here and select the version 2 here and then save it. So now this prod alias will be pointing to our updated version which has the new environment variable as well, which we just, so that's the way you can have multiple versions and multiple aliases pointing to those versions, and you can plan your blue-green deployment using that aliases. Now another pattern is about the canary pattern of release, where you want to route your some percentage of the calls to one version and some percentage to the another version, and once everything works fine, then you route to everything to the latest version. So that also you can plan it using the same template. Also you can automate it and do it. That is the same thing you can do for green blue deployment using the update alias and update function code method. In the console, how you can do it is that you can go to You can go to prod alias, and then there is an option for additional version. So now if I select the version 1 as additional, so here you can give the weightage, that how many percentage of traffic you want to shift. So you can define 10% of the traffic I want to shift to the version 1, and the rest will be 90%, and that way you can do the canary deployment. So let's talk about the last topic of this session, which is some miscellaneous tips I would like to share with you. Lambda provides very good console to develop the code, but that is only for the basic code which you want to try it out. For production level of coding, you should not be using this Lambda console because it does not provide you any code versioning automatically. So if you make a small change in that by mistake and click on save button, your old changes is gone. There's no versioning available to it. Okay, so be careful when you're using the Lambda console for your coding. There's no indication available with the Git tab or any other code repository, so you cannot do again the version branching and other stuff to the console. And if you remember that while writing the function handler, you can import the AWS SDK library, which is already available there. But what if you want to import any other library? You cannot do that in the Lambda console. You have to develop that code into the local and ensure that dependency is available part of your code while pushing the code to the Lambda. So these are few basic challenges you will get it while doing the development in Lambda console directly. So better you use AWS SAM or the serverless framework for development. It not only gives you flexibility of building and doing the versioning and all those stuff, but it helps you to do the local testing as well if you use the AWS SAM. The next one is that you should plan for the continuous integration and continuous delivery also for the Lambda, like you do for all the other deliverables you have, because that will give you a way of pushing your code fast to the production. The last tip I have is that use the environment variable extensively to separate out your code from the configuration. You should not hard code your configuration or properties in your code, and especially the secrets credentials. You should use either the environment variable with the encryption helpers, or you should use some permanent store like SSM or any other secret manager you want to use. You can use that, but don't put your configuration in the Lambda code. So that's all about the tips. Thank you very much for listening me. You can follow me on Twitter as well as go to my website www.rajeshbhojwani.co.in to follow my other blogs. Thank you.